Okay, but since we are living in our country that we live in, and we do have to be able to deal with these conversions if we're going to work in the scientific community. So these are going to be very helpful. Now this is where you're going to want to go to the reference folder on the course webpage, print out that conversion sheet and keep it with you. Bring it to class, use it to do your homework problems, because there are a lot of useful conversions on there. Okay, you can certainly find those in a lot of other places. You don't have to just find it on my webpage. You can find conversion charts anywhere. Textbooks and little cards, they come all over the place. But here's some common ones. Okay. Now, this is very important because these are called conversion factors. These allow you to go from, let's say if I have a given unit of, say, kilometers, and I want to know how far that distance is in miles, for example. All I need to know is what is the relationship? How many miles are in a kilometer, or how many kilometers are in a mile, whatever, however you want to look at it. And if I know that, what I have is a ratio. I have a numerator and a denominator that are going to be expressing some sort of ratio. In other words, how much of a kilometer is equal to how much of a mile, or whatever. And if I know that, it's really easy to do the math and convert one unit to another. It's actually called dimensional analysis. Fancy way of saying converting things. Okay, here's some common mass conversions. Some volume conversions. You realize, make sure you understand some vocab here. Mass is sort of like weight, but not really. It's just the amount of matter that something has. You can think of it as weight if it helps you, but realize there is a subtle difference between the two. Volume is how much space something takes up. So you need to be familiar with the types of units and what they measure. Mass is going to be like in grams. We can take pounds, which is weight. As long as we're on Earth, we can convert that to grams and kilograms. Volume is going to be like in liters or gallons. Think of especially the things that you would measure liquids in. Cups, liters, gallons, that kind of stuff. That's going to be volume measurements. That will change a little bit when we get to solids, and I'll show you that when we get there. Okay. If you give me a number without a unit, it's wrong, because I have no idea what that number means. So make sure you know that. Numbers have to go with units. Also, treat units like variables when it comes to math. For example, if you're multiplying, let's go back to some math here. How do you find the volume of a cube? Length times width times height. Let's say that the sides of the cube, all of them were on all sides 2 centimeters. Okay? That means the length was 2 centimeters, the width was 2 centimeters, and the height was 2 centimeters. How would you express the volume of that cube? Which is what? 2 times 2 is 4 times 2 is 8, right? 8 what? Cubic centimeters. That's my point. I want you to make sure you realize you treat these units like you would a variable, okay? Like an x or a y if you took algebra. When you multiply a centimeter value and a centimeter value together, you get square centimeters. If you multiply 3, you get cubic centimeters. That's the way it works. Because that's going to be important, because you're going to have to start canceling stuff out and keeping track of all these units. So you got to get this stuff right. Okay, so like I said, this is all called dimensional analysis, what we're getting ready to start here. Some of you probably have already done this in other places. Some of you, this may be the first time you've seen this. So it's hard for me to know where everybody sits on this. So, okay, now, like I said, a conversion factor is going to be a relationship between two things. This is going to be immensely useful to you. You've got to know how to do this from the very beginning, because it gets more complicated, I promise, as we go throughout the rest of the semester. Now, it may be exact or it may be measured. It may be a definition, like there's 16 ounces to a pound. That's a definition. There's 4 quarts to a gallon, by definition. Or it could be something that you've actually measured. There are, however many of your hands equal to 12 inches, whatever. It could be measured, it could be identified, it doesn't matter as long as there's a relationship that exists there. Okay. I want you to notice this bottom part right here. There are 2.54 centimeters in 1 inch, for example. Now what you need to realize is that if you're going to use that as a conversion factor for math, what that means is that either one of these is true. We're going to express this as a ratio. This equal sign actually means that for every one of these, there's 2.54 of those, and vice versa. So we're going to put these together in fractional form and call it a ratio that we're going to use as a conversion factor. So what that means is, depending on what I'm starting with and where I'm going, as you will see in the examples, I can write that, I can express this equivalency either like this, 2.54 centimeters over 1 inch, or I can say 1 inch over 2.54 centimeters. It doesn't matter. Okay? Either way expresses the fact that they are related to one another. How you choose to write it depends upon what you're solving for. Okay? How are you going to set this stuff up? What you want to do is, like for example, if I say, here's your distance in kilometers. Tell me how far that is in miles. You're going to start with the original distance that I gave you. Then you're going to multiply by some conversion factor, some relationship between miles and kilometers. When you do that, you're going to get the answer. Now notice how this is set up. What you want to do is realize that, like in algebra, when you have variables above and below the fraction, whatever's on top and bottom can cancel out, right? If you have an x on top, x on bottom, mark them out. They'll cancel. Same thing will be here. Realize that this is the same thing as like over 1, right? So if you multiply these two things together, you would have unit 1 times unit 2 over unit 1, and then unit 1 would cancel out. That's what this is. Okay? I have a chair. Man, where all these people come from? Huh? I'm just taking them wherever I find them. I don't know. Somebody's going to come back to their office and not have a place to sit. I don't have a table for you. Sorry. You have to squeeze in. Get cozy with somebody. But if you set it up like this, what you will see is that the units will cancel out. Okay? The units you're trying to get rid of will get rid of themselves, and the units that you have left are the ones that you want to get to. So that's the way this will work. Let me put some numbers in here and try to make some sense of this. Okay? Now, what you will see as we go along, when you get good at this, we're going to be able to string this out. We may be able to put like 6 steps in here, and everything will cancel out as we go, and we'll end up with the answer that we want in the very end. But we'll get there. Okay? All right, so let's take this example. If I ask you this, convert 7.8 kilometers to miles, how can you do that? Now, I know that like in your head, you could probably do this. Or at least like if I said 3 dozen donuts, how many donuts is that? Or 36, right? You can do that in your head. I don't want you to. And the reason is not just to be difficult. The reason is because I'm preparing you for a future chapter, in which case you will not be able to do these things in your head. Get the method down now while the problems are easier. Okay? All right, so 7.8 kilometers. I want you to convert that into miles. So here's what you're given. Here's what you're trying to find. What do you know? Is there a relationship that is known between kilometers and miles? Well, this is where a conversion sheet would be very handy. You would look it up and you would find a relationship there. In this case, this is known. There is 0.6214 miles in 1 kilometer. Okay? So, where are you coming from? What unit are you leaving, and what unit are you trying to get to? You are leaving kilometers and trying to get to miles. So the question then becomes, how do you arrange, how do you position your units so that they will cancel out properly and you will be left with the unit that you want in your final answer? Well, this makes sense if you look at it like this, right? If you know that this, whatever ratio this is right here, it has to be this equivalency, this conversion factor. So put it here. If I put miles on bottom, will they cancel out? No. I want to get rid of kilometers and I want to be left with miles. So I'm going to have to put kilometers on the bottom. They will cancel out. And then whatever number I start with, it'll end up being 7.8. When I start multiplying that together, the unit that I'm left with is going to be miles, and that's what I want in my final answer. Okay, so look at the solution. I start with what I know on 7.8. What can I multiply that by in order to get to miles? Well, I know that this many miles are in this many kilometers. Okay, so these will then cancel out. And notice that when I multiply these numbers together, I'm going to be left with the unit that I want, miles. That's the way this is going to work. Now, what about significant figures? This is actually a measurement. See all those decimal numbers there. Okay. Now, 1 kilometer, well, actually, since this is a conversion factor that you look up on a sheet, we're going to say that anything that you look up on the sheet like this, that is a defined conversion factor, it is not going to have an impact on the number of significant figures that you have in your answer, because it's not something that you measured. See what I mean? It's not something that was limited by the instrumentation that you were using. Therefore, you can just use it for what it is. And what you're going to be limited by would be this 7.8, because that is a measured distance. That's not a definition. Now, you may not have personally measured it, but you're given that quantity, and that had to have been a measured quantity because, there's an infinite possibility of the number of kilometers that exist, right? So you're given 7.8. That was some measured quantity by somebody. That's what's going to limit your significant figures. This is a definition. This is a conversion factor that you are using, okay? That will not limit it. So, in other words, you are limited to, this is a perfect number, so that's not going to affect your significant digits. Here you've got 2 sig figs that you need to worry about. So you would take this long number, and it's a multiplication, so you're limited to the least number of significant figures that are present, which in this case is 2. So you would take that number to make it 4.8 miles. Okay? So the answer is, how many miles are in 7.8 kilometers? 4.8 miles. Follow me?